Hi, welcome to the final exam review examples part A. You'll notice that each of the review examples are going to be split into two types of problems. You're going to have A problems and B problems, and then the numbers will match and be similar. So in each video, I'm going to do just the A problems, and then we're going to do the second video and look at the B problems so we can see how to use the review examples to help us with similar problems. Okay, so starting with 1A. Triangles below are similar. What is the perimeter of the second triangle? So this was from Unit 5 at the very beginning of this semester, and we said that you can find the scale factor between two figures using these sides. So my scale factor is going to be 4 to 8, which I can reduce, but I really don't need to. The ratio of my perimeters will also reduce the same. Now, if I put 4 in the numerator, I have to make sure that I stay consistent with numbers from the pink triangle in the numerator and the teal triangle in the denominator. So when I look at my perimeters will also reduce to the scale factor. My perimeter from my up triangle is 17, and from the down triangle, that's the one I'm trying to find. So that is going to be my x. And for here, all I need to do then is cross multiply. 4 times x and 8 times 17. So when I do that multiplication, 4 times x equals 8 times 17, 136. So to find x, all I need to do is do my division property of equality, divide both sides by 4, and x equals 34. My units here are centimeters. All right, let's look at 2a. Find the value of x. I can see I have an isosceles triangle. And I remember when I draw an altitude in an isosceles triangle, it divides the base of the isosceles triangle into equal halves. So if the whole thing is 10, I'm going to have 5 and 5. So then what I'm going to do is I'm going to look at just one side and go, oh, I have a little right triangle there where I know a hypotenuse, I know a leg, and I'm trying to find the other leg. So to find the other leg, I'm going to do the difference of the square of the hypotenuse and the other leg. So that leg, x, is going to equal 12, the square root of, actually, I'm going to just put that in my calculator since I have the graphing calculator open. The square root of 12 squared minus 5 squared, which is 10.909. I'm going to round that to 10.909. And I don't have units here, so I'm just going to say units. Okay, let's look at 3a. A captain's GPS tells him that he is 40 meters away from treasure. He walks 24 meters west. The GPS now tells him that the treasure is south of him. How far south does he need to go? And I have this picture. I know if he moves west and then he moves south, he's making a 90-degree turn. So again, I'm looking for this leg here. I know a hypotenuse. I know the other leg. I need to find the missing leg. That leg is equal to the difference in the square of the hypotenuse and the other leg. So this is almost the same as the last problem, only it has a word problem that goes with it. Square root of 40 squared minus 24 squared is 32. So he needs to go 32 meters south to find the treasure. Let's look at 4a. 4a, find the value of x. Make sure your calculator is in degrees. Well, there's only one reason we make sure to put our calculator in degrees, and that is because we did trig. So, ka, toa. So since I know I need my calculator in degrees, I'm going to go ahead and write that down. For degrees, remember we click on mode and then make sure that degrees is highlighted. So on my calculator mode, it's not highlighted. So I'm going to arrow down and over to it and hit enter, and I can see it unhighlights the word radian and highlights degrees. To get back to the calculator screen, I hit second and then mode because that quits me back to the screen. Okay, so now what we're going to do is we're going to say, what angle do I know? Or what angle am I trying to find? In this case, I know angle B is 57. So what acute angle do we know? That is where I'm going to be standing. Coming out of that angle, one side is the hypotenuse, one side is the adjacent side. The hypotenuse is across from the right angle. So that means this is my adjacent side. And then the side all the way on the opposite side is my opposite side of the triangle. So then what I'm going to do is I'm going to circle the two sides that I know or that I'm trying to find. So my opposite side is 10.8 and my hypotenuse is x. So I know the opposite side, I'm trying to find the hypotenuse. So opposite and hypotenuse, the trig function that I want to use here is sine. The sine of the angle is equal to the ratio of the opposite over the hypotenuse. My opposite is 10.8. My hypotenuse is x. To solve this, anytime you're trying to find a side, you cross multiply. If you're trying to find an angle, we inverse. I'm trying to find a side. So I'm going to cross multiply, and I'm going to get x times the sine of 57 equals 10.8 times 1. To solve for x, since I don't have x equals, I have to get rid of that sine of 57. So I'm going to divide both sides by the sine of 57. Okay, when I do that, I get x, now I have x all by itself, equals, and then it's just this fraction, 10.8 divided by the sine of 57. That's going to be 12.878. And these are just units. Okay, 5a. Find x to the nearest degree. Make sure your calculator is in degrees. So I'm still working with trig, so katoa. And the angle that I'm standing at, the angle that this time I don't know it, I'm trying to find it. So I know this time is a little different. I'm going to use inverse. I'm at angle A. Coming out of that angle is my hypotenuse and my adjacent side. Across from the 90 is my hypotenuse. The other is the adjacent. And then the side across on the opposite side is the opposite side. So the two sides that I'm working with are the opposite and the adjacent because I know both of them. There's no sides I'm trying to find. Opposite and adjacent. So I'm going to use tangent. Since I'm trying to find the angle, I'm going to use inverse this time. So the inverse tangent of the ratio, opposite over adjacent, 11.9 over 10 is going to give me that angle x. Okay, so to use the inverse tangent, I have to use the second and the tangent button, and then 11.9 divided by 10. And it says to find x to the nearest degree, so that's a whole number, so that's going to be rounding to 50 degrees. 50. All right, let's look at 6a. For the parallelogram, find x. So since they told me it's a parallelogram, I know I have parallel sides. So I know this side here is parallel to this side here, and my top and my bottom are also parallel because it's a parallelogram. Okay, and I have my diagonals drawn in. So my diagonals are like parts of transversals of those parallel lines. If I look at just the part that I highlighted, I have this 60 and this x are alternate interior angles. And if I have parallel lines, my alternate interior angles are congruent when I have parallel lines. So that means if one is 60, the other is also 60. So x equals 60 degrees. Okay. 7a, true or false? The diagonals of a rectangle are perpendicular. Well, let's see if we can draw a rectangle and see if that's true or false. Okay, so a rectangle, perpendicular. I'm going to draw my best rectangle. I know it's not perfect. And then when I draw in those diagonals, perpendicular means they intersect at a 90-degree angle. So when I draw these in, 1 and 2, that's saying that all 4 of these angles are all 90 degrees. Okay, hopefully you can see that you're going to have, if you have a really long rectangle, you're going to have one obtuse angle in the center and then an acute angle, right? And then pairs of them, right? Because your vertical angles will match each other. So we're going to have two little acute angles and two obtuse angles. The only time you'll have a rectangle where your diagonals are perpendicular is when your rectangle has all four sides the same and it's a square. So this is actually a false statement because here is a counter example. Okay, let's look at 8a. For the isosceles trapezoid, find x. Now, they tell me it's an isosceles trapezoid. That tells me that my base angles here and here are equal, which means if I've got 22 and 45, I've got 22 and 45. Really, that 45 is the part that's important because I'm going to use what I know about triangles now that I've used what I know about the isosceles trapezoid. When I look at this triangle, I know the three angles of a triangle add up to 180. In this corner, I've used 22 plus 45 degrees. In this corner of the green triangle, I've used 45 degrees. So in this green triangle, I've used 22 degrees, 45 degrees, and 45 degrees. So when I add those together, 22 plus 45 plus 45, I get 112 degrees. I know every triangle has 180 degrees. So if I take away that 112, it's going to leave me with what's left for x. So 180 minus the 112 is 68 degrees for this angle here. So 68 plus this angle makes the triangle. All right, let's look at 9a. Find the value of x in the kite below. Okay, so I have a kite, which means it has a top and it has a tail. My top and tail angles are different always, but my side-to-side angles are always the same. Now, because it's a kite, that also means it's a quadrilateral, and the quadrilateral has a sum of its angles equal to 360. So if I've used 110 degrees for the top angle and 22 degrees for the bottom angle, I've used 132 degrees out of the 360. So that's going to be 360 minus 132. Says I have 228 degrees left for these side angles. These side angles are the same. So if I make that into two equal angles, then each angle is 114 degrees. So this angle is 114 and this angle is 114. All right, let's look at number 10. Number 10, the figure below is an image that has been translated using the coordinate notation xy translates to x plus 2, y minus 1. What are the coordinates of point A in the pre-image? Okay, so this is the image. This has already been moved x plus 2 and y minus 1. Where was A to start with? Okay, so I have to work backwards. I had to go to the right 2 and down 1, okay, to get to A prime. So if I want to work backwards, I'm really going to go to the left 2, and instead of down 1, I'm going to go up 1. So really, A would have been here, so that I'm going to the right 2 and down 1 to get to A prime. So A had to have been at 0, 4. A had to have been at 0, 4. We had to work backwards. Because they gave us the A prime and we wanted to work backwards to the A. They gave us the new point. We wanted the original point. Okay. All right, let's look at 11. Reflect the figure below across y equals x. So y equals x, in case we have forgotten, is our parent function. Our uphill linear equation parent function, y equals x. And if I don't remember the rules for reflecting across y equals x, that's why we have in our resources, we have our formula chart. Okay, so down to resources, formula chart, my rotation rule or my transformation rules. If I'm reflecting in y equals x, it says xy becomes yx. Xy becomes yx. Okay, so what I need to do is I need to take each one of these points and I need to switch their points. So I'm actually going to rewrite it over here. Xy becomes yx. Okay, so if I start with point x is at 1, 2, 3, 4, negative 4. And then y, 1, 2, 3, 4, 5. So that means it's pre-image. This is x, or sorry, it's image x prime. I'm just switching those. So now 5, negative 4. 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. This is x prime. Let's go A next. A is the point 1, 2, 1, 2, 3. 2, 3. So that means A prime is going to be, we're just going to say y is 3, x is 2. 3, 2. 1, 2, 3, 1, 2. A prime. T, let's go T next. Negative 2, 3. T is at negative 2, 3. So T prime, y is 3, x is negative 2. 3, negative 2. 1, 2, 3, 1, 2. Wait, something. Oh, sorry, this was 3, 2, and look how I graphed it. I was like, wait, I've already got that point graphed. This should be, A prime should be at 3, positive 2. 1, 2, 3, positive 2, A prime. And then T prime is at 3, negative 2. 1, 2, 3, 1, 2, T prime. All right, and then last but not least is S. S is the point 1, 2, 3, negative 4, 1. So S prime, y is 1, x is negative 4. So 1, negative 4. 1, negative 4. S prime. So x, s, t, a, x. There is my reflected image. And you can see that each point is the same distance. If I go across diagonally, 1, 2, 3, 4 and a half, 1, 2, 3, 4 to get to its image. If I were to fold along this blue line, these points would line up perfectly with these points. Okay, let's look at 12. If B, negative 2, 6 is rotated 90 degrees, what are the coordinates of B prime? So I am going to go and look at my rotation rules for 90 degrees. Rotation 90, xy rotates to opposite of y, x. Xy rotates to the opposite of y, x. So B is at negative 2, 6. So B prime, the opposite of y, the opposite of 6 is negative 6. X is negative 2. B prime is at negative 6, negative 2. Okay, and last but not least, let's look at number 13. Given the radius of 5, find the length of GH. So to find the length, we said to find the length of an arc, we use the measure of the arc divided by 360, because that tells me how much around the circle out of the 360 degrees am I using, times, and if it's length of GH, that means I just want to know if I took this piece of the circumference and I cut it out and straightened it, how long would it be? So notice I said if I took this piece of the circumference, right, of the perimeter, my circumference is 2 pi r. Okay, so the first thing I need to do is I need to know how big is the arc, which means I need to know how big is this central angle. I have a segment here. I know on any side of a line I have 180 degrees. I've used 20 and 90, so let's see what's left. 20 plus 90 from 180 leaves me with 70 degrees. So that's the measure of the arc, but I want the length of the arc. The measure of the arc is 70 out of 360 times 2 pi r. My radius is 5. So 70 divided by 360 times 2 times 5. Notice I didn't put the pi in there. And I'm going to turn this into a fraction. Math fraction, enter. My exact answer is 35 over 18 pi. The approximate length then is times pi, 6.109 when I round correctly. My units, it doesn't tell me, so these are just units. And it's part of the circumference, so they're plain old units. It's not squared or cubed or anything, it's just plain units. Okay. All right. In the next video, we're going to look at the B versions of the questions and see how we can use the first review question to help us answer the second review questions. Okay. All right. Thank you so much for watching, and come on back for the B problems of part A. Thanks for watching.